Morning. It's Marita Kotze speaking. I am the Senior Education Specialist for Physical Sciences at Impact. Very welcome to all of you, and we are just going to wait a minute or two for everybody to log into the session. Thank you for attending this session this morning. I see they are still busy attending, logging in, so yes. Let us just wait a minute. Okay, while we're waiting, I hope all of you are staying safe and nobody ill yet. Keep well. So yeah, this is exciting times for us. It's very different for us, but this is exciting times also. I hope all of you use this time now to start preparing for the exam that you're going to write as a trial, not as an exam. So cool. Hi. Just see. I can hear somebody on the other side. Are you muted? Good morning. All right. I think I'm going to start. I think everybody, all the attendees are already logged in now. So yes, let us start the session. My name is Marita Kotze, Senior Education Specialist for Physical Sciences. And before we begin this webinar, let's just cover some of the basics. If you are struggling to hear me, make sure your audio is on and your speaker volume is turned up. You will automatically be muted. So should you have any questions, you can ask your questions in the question box on the right or below. Click on the icon on your dashboard below or to the right. If you want to raise your hand, or if you want to send me an inbox, or if you want to send me any message, you can do it in the message question box, and that's also to the right or below your screen. All right. You will also find all this information in the question box below on your right. Remember to send me your questions during the session or after the session. You can send me a question to academics@impact.co.za or to info@impact.co.za. And this webinar that you're attending now will be available on Impact's YouTube channel. And because this session is being recorded the whole time, and so you can download that as well to listen again at it and look at it again. And you can also, the Impact learners, you can also download it from the Impact platform, the learning platform. So yes, feel free to do that. And if you're not at Impact, you can send me an email to academics@impact. Send us an email. All right. Now, what we are going to do today is chemical change. And chemical change is physical change. We are going to look at physical change, chemical change, law of conservation of mass, and law of conservation of composition. Now, the reason we're doing this is, and this is very important, is this form part of the basics of your physical sciences chemistry part for grade 11 and 12 as well. Remember, you're going to write in grade 11 and 12 about some of the things that you're doing in grade 10 as well. So you must make sure that you do understand this each and everything before you can go on. So make sure. So what are the difference between physical changes and chemical changes? It's just a summary that I want you to look at this morning. When we have physical changes, it means that the method changes but form but not chemical identity. For example, if we look at melting ice, ice is water in a solid phase. The moment when it starts melting, it's still water, and then it can vaporizes. It's still water, so it stays water. So the chemical identity of water will still be the same. If you chop wood, you're changing the wood into pieces, right? So it will still be wood. Nothing will happen to it. Paper, if you shred paper, it will still be paper. So it's physical changes. You handing the paper and you shred it, but it will still be paper. The same with gray and green marbles. It will still be marbles. If you're mixing the gray and the green marbles, it will still be marbles, but it will be mixed of the gray and the green marbles. Now, all right, what therefore then will be a chemical change. Now, a chemical change is where you do something to the physical part of the object that changes it. Okay, you cannot, if you burn wood, you cannot, and you turn into ashes. You will see I will use this example through the whole webinar for you to understand why burning wood it turns into ashes. So a rotten banana, it will be rotten. Firewood, and mixing vinegar and baking soda and fireworks. So all of it, the moment when it's the chemical reaction takes place, and it ends at the end. All right, so that is a chemical change. Now, if we look at physical change, so we say it's a substance and its physical properties is not affected. So substance affects its physical properties, but nothing else happens. Physical means ice into water. That is a physical property that you change, but it will still be water. There is no new substance. No new substance. It means that if you have ice, it turns into water. So the substance is still H2O, although it turns from a solid to a liquid. So it's no new substance. The physical properties change. It's from a solid to a liquid. That's a physical property. All right, so the physical changes are usually reversible. So you can put the water in the fridge again and it will be solid again. So it is usually reversible. So the particles stay the same, but the arrangement changes. All right. So this is a physical change, therefore, because water is changed into ice, which is a liquid, and it's just a change in state of matter. Okay, state of matter or phases of matter. All right, so physical change can be either a change of phase or state, a change of shape, or it can be a color change. All right, so now if it is a change of phase or state. We say it changes from a solid to a liquid. So the phase or the state was solid, and then it turns into a liquid. The three phases of matter is solid, liquids, and gases, or solid, liquids, and gases. So yes, the phase of the substance can change. Chemical composition of the substance remains the same. These are the properties that you must know and understand. All right. So the chemical composition, it's still the water, it's still H2O. There are small energy changes involved. It's from when it's 0 degrees Celsius to the moment when it starts melting. It's at 1 degree, it's already starting to melt. All right. So the processes that can be in changes of phase or state is melting, evaporation, condensation, freezing, or separation of mixtures. Now, what is a separation of mixtures? If we look at our physical change examples that we did that we have here, all right, we can see that the physical is from ice to water, from water to ice. All right, so that is, but what about, what can we separate? We can separate the gray and the green marbles. It's easy. We can separate it. It's the same with other separation methods that we're using. It's, for example, distillation. So that is one separation method. Okay, or we also use evaporation and then condensation again. That is all part of the methods that we can use in the changes of phase or state. So the following remain constant. That's very important with physical change. It's the size and the mass of the particles, the shape of the particles, the number of the particles. So these three things remain constant. The moment we see that there's a change of number of particles or shape of particles, what are the shape and the number of the particles here? It's, for example, H2O, it's 3 atoms, okay? It's 2 hydrogen atoms and 1 oxygen atom. So that is the number of particles that stay constant. Okay, the moment when we change water into hydrogen and oxygen again, then we will see that it's the shape of the particles changes, and that is a chemical change. All right. So if we decompose this water into hydrogen and oxygen again, then it's a change of shape and of the number of particles. So therefore, that is not constant anymore with chemical change. All right. So what are one other factor that can change? It is shape. So the chemical composition remains still the same. The shape, only shape changes. Clay that is molded, for salt that is grounded, sugar that is grounded. So that is the change of shape. Here we have ice into liquid, into gases. Here we have coarse salt that we change into fine table salt, or sugar that you change into icing sugar or caster sugar. That is a change of shape. The other one is color change. So how does the color change? The chemical composition remains the same. So you can heat it and it turns into, say for example, when you heat it, it changes color, and the moment when it cools down, it turns back to the original color. So that is one other factor that can, one other physical change. All right. It's only a temporary change. When color changes permanent, it is a chemical change. All right. For example, iron rod. I'm not sure which of you do have or did see where you heat a piece of steel and it's like it's steel is normally it's either shiny or it's black. And when you put it long enough into the fire, you will see it turns into red as and the red orange red if you put it in a fire. So that is a change of color. But the moment when you cool down the iron rod, it turns black again. So it turns red while it's hot and it's in the fire, but the moment when it cools down again, it turns black. All right. So now chemical change. What is chemical change? Here we do have a fire. So what is happening with a fire? It changes of matter that produce new substances. When we have wood and we change it into and we start burning a fire, it changed into changed into ashes. Ashes, I will do that now. But so therefore, that is an example of a chemical change. The new substances have chemical properties which are different from the original substances. On the one side, you have wood. On the other side, you have ashes. So that is a definite chemical change. All right. So chemical changes are usually difficult to reverse. You cannot change the ash into wood again. So the particles changes because the bonding between their atom changes. All right. So changes that occur during a chemical change, it's a permanent color change. A gas can be given off. There's a change in temperature. A precipitate is a solid that can form when two liquids are mixed. Light is emitted. Now, can you think of others? You can start thinking about something else. I just put in a few here that's more likely to change. Also, the chemical bonds are broken. New chemical bonds are formed. Wood, ashes, what we have on the one side is wood. The wood turn into ashes, so the ashes cannot be turned into wood again. So new chemical substances are formed and chemical composition changes. All right, chemical composition changes. So here we do have the example that I told you about. So what is happening here? You can't change the ash back into wood again. So this is the ash is a different type of matter. The chemical change is therefore permanent. All right. So chemical change, one thing that we do is the decomposition reaction. We have hydrogen peroxide, and hydrogen peroxide, when you start heating hydrogen peroxide, you will see that there's bubbles here, and the water, water is formed. All right. As you can see here in the bucket, the blue liquid that you can see here is the water, and the bubbles that you can see here is the oxygen gas and the liquid water. So with the decomposition of hydrogen peroxide, can you see the formula is almost the same as water, all right? But it's two different products, okay? Water is H2O, hydrogen peroxide is H2O2. So hydrogen peroxide, the moment when you start heating it and you're heating it long enough, it turns into water and oxygen. So some of the oxygen atoms decomposes from the water molecule to form oxygen gas again. Oxygen gas is a diatomic molecule, that is diatomic molecule is a term that you learn in term 1, that you must be aware of what is diatomic. Diatomic means in its normal state, it is a gas in nature. Okay, oxygen cannot only be one atom. So oxygen is always in nature. It consists of 2 oxygen atoms, and we have an oxygen diatomic molecule here. All right. So now we have new substances that formed. Therefore, this is a chemical reaction. All right. Another thing that we do is a synthesis reaction. Now a synthesis reaction is where you put two elements like iron and sulfur together in a test tube. And you can see there at the bottom is the yellow-orange part here at the bottom of the test tube. That is the sulfur. Okay. The gray part there on top is the iron fillings, iron filings. So yes, what is, you have 2 different elements here. The moment when you start heating, here you can see the gray part. The moment when you start heating it, you can see that it starts changing. All right. So now a new substance is formed. Therefore, it is a chemical reaction. A new substance forms. Therefore, it is a new chemical compound that we do have, iron sulfide. Now, iron sulfide cannot change into iron and sulfur again. You cannot not have the yellow sulfur powder and iron filings again. So this is a permanent change. I put the YouTube link in here for you. It's a really spectacular thing to see. So it's just go on this YouTube link and you can look at it. It's just a few minutes. You can see what is happening with the iron and the sulfur. So what we do have there is we have 2 substances. All right, we have sulfur and we have the iron filings. All right, and both of these 2 substances, or both of these elements, when you add them together, there we have the yellow and gray mixture. The yellow and gray mixture. If you do not heat it, you can separate it again. You can separate this mixture again by using a magnet. A magnet will attract the iron filings, and therefore you can separate it again. So then here it is a physical change. It changes from sulfur powder, that's yellow, a gray powder, that's the iron filings, and when you mix it together, you have a mixture of iron filings and sulfur, and you can separate it. So by separating these 2, then it's a physical change. But the moment we add heat, there's a permanent change, and it turns into a black, it's not a powder anymore. It's a black substance. It's bigger particles, but it's not. You can see here there's no gray and yellow particles in here anymore. So here is a permanent change. All right. So now what is the law of conservation of mass? It states that matter is neither gained nor lost during a chemical reaction. So if we have 32 grams of sulfur, so by the way, this is the relative molecular mass of sulfur. This is the molecular mass of sulfur in grams. Plus we have 56. This is the relative, this is the relative atomic mass of iron, and this is the relative atomic mass of sulfur. When you add both of them together, we have the formula mass. And when we put it in grams, it's 88 grams. So when we add the two together, it must be constant. The product spot, if you weigh it, you will see it will be constant. It will also be, when you add it together, it will be the same. So you can say the left-hand side equals the right-hand side in mass. It's only in mass. So we say with the law of conservation of mass, what goes in must come out. What goes in is it is the mass. The mass, what goes in must come out. Okay, regarding the mass here, it's a statement regarding the mass. So we also say that mass is neither created nor destroyed in ordinary chemical and physical changes. Okay, so the mass is neither created nor destroyed in both in ordinary chemical and physical changes. So it doesn't matter if it's physical or chemical, both of them must stay constant. All right. So you must start and end with the same amount. This is a very important fact that we use in grade 11 and 12, as well as in grade 10. The previous webinar that we did, if you didn't attend the previous webinar, you can download that from My Impact. We did the empirical formula and the molecular formula and the composition, the percentage composition, and all the other calculations. And there you will see that by calculating the different by adding them together, you can see that both on the left-hand side, the reactants, the molecular mass or formula mass of the reactants will, when you add them together, of the separate subjects of the separate elements, it will be the same as the products. So the relative atomic or molecular masses or formula masses will be, when you add them together, the left hand must be equal to the right hand. So what is the definition of the law of conservation of mass? The law of conservation of mass states that the total mass of substances taking part in a chemical reaction is conserved during the reaction. Its state constant is conserved. So another example of the conservation of mass is methane and oxygen. All right, here we do have, I showed you here, you do have the shape of a methane molecule and the shape of the oxygen molecule and the shape of the carbon dioxide molecule and water molecules. Okay, so what is happening here? The 16 grams again, carbon, the relative atomic mass for carbon as you find it on the periodic table. Please, learners, make sure that when you're busy with both chemistry and physics, that you use the formula sheets that are attached to the test papers. All right. So if you're busy with chemistry, you can always put your your periodic table next to you and start using the periodic table as a tool, that periodic table. And each and everything that you want to write on that periodic table, write it on the periodic table. That formula sheet is for you to keep. So use it, start using it as a tool to become familiar with it, so that when you get it in the June exam paper, you will be able to read and use that as the tool that it's supposed to be. All right. So the relative atomic mass for carbon is 12. The relative atomic mass for one hydrogen atom is 1, but there are 4. So 4 multiplied by 1 is 4, and so 4 plus 12 is 16. Now 16 grams means this is 1 mole. This is 1 mole of the methane compound, 1 mole. Now the oxygen, 2 oxygen molecules. Again, 1 oxygen atom is 16 grams. When you have 2 of them in a molecule, it is, you add them together, it is 32 grams for 1 molecule. So 2 multiplied by 16 is 32. 32 multiplied by 2, what 2? That is the 2 that we do have here. All right. So make sure that you know how to use these calculations. If you're not sure, please make sure that you ask a question that I can answer your question and email it to me or put it in the question box to the right or below. All right. So now carbon dioxide. As we have on the left-hand side, carbon dioxide will still be 12. Oxygen still be 16. We have 2 oxygen atoms, 2 oxygen atoms on both sides. We have oxygen atoms, so 2 of them. So it's again 32 grams plus the 12 grams, and that is 44 grams. Water, again 16, only 1 oxygen atom, 2 hydrogen atoms. It's 2, so the relative molecular mass of water is 18 grams, but we have 2 water molecules. So 2 water molecules is 2 multiplied by 18, and this is 36 and 44. 36 and 44 is 80 grams. So when you measure it on a scale, the reactant's mass must be equal to the product's mass. All right. So now, what is the law of constant composition? The law of constant composition is that the compound contains elements in a certain fixed proportion. Okay, fixed proportions, ratios, meaning ratios. You will hear this this term, you will hear and use this numerous times in chemistry and physics. So make sure that you understand what is the meaning of ratio, and in no other combinations, regardless of how the compound is prepared or where it is found in nature. So law of constant composition, water is water, hydrogen peroxide is hydrogen peroxide. If we look at methane, methane is CH4. It's only CH4. CH4 is only methane. H2O is only water. That is the constant composition of water. The constant composition of carbon dioxide, the constant composition of methane. So what is the law of constant composition? It states that a specific chemical compound always consists of the same elements in exactly the same ratio. This is a definition that you must learn and know. So please, learners, if you don't learn the definitions up until now, write down all your definitions. All right, put it inside your cupboard. So each and every time you open the cupboard of your closet, or just put it everywhere where you can see it, so that you can learn the definitions. Learning each definition per day, or a definition per day, is much easier than learning 20 or 30 definitions the day before you write an exam. So please, learners, if there are a definition or a law, write it down, put it in a file for yourself. Make sure that you do know and understand the laws and the definitions that are easy marks in your question paper. So now, the law of constant composition of a water molecule. So what do we have here? This is the molecule, the water molecule, right? We have one oxygen atom and two hydrogen atoms. So water will always be composed of two hydrogen atoms and one oxygen atom. That is a constant. All right. So what is the meaning, the percentage composition meaning of this? That 12% of the mass is hydrogen and 88% of the mass is oxygen. It will always be the same. So what will the ratio then be? All right. The ratio of the number of atoms to oxygen is 2 to 1. 2 hydrogen atoms to 1 oxygen atom. The ratio for the percentage composition is 12 to 88%. That's both of them is, if you add it up, it's 100%. It doesn't matter how much you have. If you have a cupful or an ocean worth of water, it will still be water. It will be constant. All right. We're looking again at the reaction of the methane and the oxygen. So methane will always be composed of one carbon. The black atom in the middle is one carbon. And we have 1, 2, 3, 4 hydrogen atoms plus 2 oxygen molecules. 2 oxygen molecules will always consist of 2 oxygen atoms that are covalently bonded to each other, to form the covalently bonded carbon dioxide, consisting of 1 carbon and the 2 oxygens on both sides. So carbon dioxide will always be composed of 2 oxygens and 1 carbon, while water will always consist of two hydrogens and 1 oxygen. All right, if we look at the ratio here, we will see that the ratio is 1 methane to 2 oxygen molecules. So your ratio will be 1 to 2. If we think about the volumes, law of constant composition means the volume of the elements must also be the same. So 1 volume of methane gas, 2 volumes of oxygen gas will be constant. This will be in a constant. If it's at STD, you will see it will be, the one will be 22,4 cubic decimeters. Remember the webinar that we did last 2 weeks ago. All right, on the right hand side, the ratio is also 1 to 2. So again, we have carbon dioxide gas, water gas. These, both of them, they are gases. Methane gas, oxygen gas turn into carbon dioxide gas, water gas. So If all of them, all of them are in the same phase, then we can say 1 volume of methane gas plus 2 volumes of oxygen gas turn or form into 1 volume of carbon dioxide gas and 2 volumes of water gas. So it's a water vapor that we do have here. All right. So now I always put this part into the webinars for the learners that didn't attend our previous webinars. So we have additional resources. The additional resources that we do have now, Dr. Hinshaw do have in the I will explain it just now. Dr. Hinshaw, the Quanta Boost, and you receive, these are the products that you receive in your package this year. For the learners that's not impact learners that are attending this course, you can buy the Quanta books. I will give you the information just now. Science Clinic. Let me just explain all of them to you. So, all right, in your package, you did receive the study guide. Your mother received the facilitator's guide. The reason for that is that your mother makes sure that you follow the study guide and what you need to do in both for physics and chemistry. But learners, please, if you don't have the calendar that accompanied the study guides and the facilitated guide, you can go onto my impact and download it from there. You will see there's a part assessment, and if you get subject per content, content per subject that you can download from my impact. That is for the learners that's not impact learners. That is our platform where learners can download certain where they download their tests and exams, and there's also a part for resources. So download the calendar that accompanied the study guides and the facilitators guides if you didn't do yet. So in the study guides, we have summaries and mind maps. And the question papers, I give it to you or gave it to you up until now as handouts. And I will, if you didn't receive it yet, some of the question papers, then there are also other question papers on our impact platform and the guided learning platform. So make sure that if you don't have the question papers, you can also send me an email to impact or academics at impact. All right, so the mind maps at the end of each unit is it's a 1 or a 2 or a 3 page. It's not more than that. You can copy it or take it out of your study guides and use that as a summary with your summary. Okay, because this is what you're going to use for exam preparation and test preparation. By writing all the information that you need, that you think is also important that you need to know, and very important are the formulas that are not on the formula sheet that are in the study guides. Now, learners, please, I do have numerous questions and emails about why are they using this formula. It is not on the formula sheet. Learners, if it's not on the formula sheet, it's in your study guides. So that's why I asked you and told you to take the formula sheet that's attached to your test paper and make sure that you write on that formula sheet all the formulas that are not part of the formula sheet and learn that formulas so that you can be able to use the formulas as well in question papers. All right. Exercise books. They have exercise. You can order exercise book from them. You can go on their website and you can order it from the web. You can see all the contact details are there. Here are the website, and past exam papers. They also have past exam papers for free on their website that you can download, or you can buy previous exam papers from them or order them from the Dr. Henshaw website. If you don't have, or you do need any assistance with that, you can also send me an email and I will give you the other email addresses. Now the Quanta books. This is a very important tool that the impact learners do have and did receive this year with their packages. The Quanta books also have a summary in it, as well as question papers with memorandums at the back. Questions about all the different sections with the memorandums at the back. There are 2 very valuable DVDs at the back of your Quanta books. Please, learners, if you didn't use it yet, please go and start using the DVDs. It's Mimi Pretorius is an excellent qualified physical sciences teacher. You can look at her lessons and she's explaining it with animations and videos in it, as well as certain things that she's making. It's very, very good, and it's small. It's 10-minute lessons. It's not long to look at. Some of it's 5 minutes, but make sure that you start using your DVDs. For the learners out there that are attending this webinar today, if you want to order it, you can order it from this email, from this at this website. You can order it. All the details are there, but please, it's not very expensive. Maybe it's between 170 Rand or 200 Rand, including the 2 DVDs. That's very important. All right. One other thing that I want to make sure that you do understand are the multiple choice questions. Learners, multiple choice questions are easy marks, and it's not an eeny, meeny, miny, mo question. They are not eeny, meeny, miny, mo questions. All right. So very, very valuable are the multiple choice questions, the memorandums of the multiple choice questions. They are explaining it. All right. Explaining why it's A and not B and B and not C. So please make sure that you do understand that. All right, and then we have the Science Clinic notes. The Science Clinic notes, it's smart. You can download the notes from their website at scienceclinic.co.za books, and they also do have exam seminars where you can register, go on their website, download for free the extensive. You can see at the back of the English. If you're an Afrikaans learner, you can download the English prep book as well, because there are mathematical skills at the back of the Science Clinic notes that is necessary for grade 10, 11, and 12. So learners, thank you for attending this webinar today. If you do have any questions, send an email through to info@impact.co.za if you're not registered with Impact, and you can also send your email, your questions to academics@impact.co.za, or you can write your questions just now below in the question box that are given here. Okay, thank you very much for attending today's lesson. I hope you learn a lot. And today, so yes, see you next time. Have a nice weekend, and you're welcome to send me an email. Goodbye.